Okay, we're going to look at how to mathematically solve one of these. And it looks kind of like Hess's law. So we're going to have target equations and things like that. So on example 11, it says that we're looking to find lattice energy. All right. So the way this works is that there's going to be the target equation, which is the final answer. And then the last step, when we add everything up, is the lattice energy. So I'm going to put the lattice energy kind of down here at the bottom, but not the very bottom. So remember, from this the notes over here, lattice energy is a charged gas plus a charged gas equals a solid. Not normal chemistry. Charged gases make a solid. So we're going to put that down here. So if we're making MgF2, that's going to be Mg plus 2, because that's the charge that magnesium makes, and that's a gas, added to chlorine. Sorry, not chlorine. That's a lie. It's a fluorine. Fluorine minus 1 as a gas. And then it's going to make MgF2 as a solid. And it says find this. So this is what we're looking for. So delta H lattice. This is what we're looking for. Notice it's the charged gas, a charged gas equals the solid. Okay. Now, this is the last step in an addition problem. So what I'm going to do is I'm going to draw a line here like that, and I'm setting up a big fat addition problem. So the answer is going to be delta heat of formation. So we're going to look at that at the end. And the answer is actually the target. So down here, we're going to create the target. So let's just go step by step. And now we're going to start up here at the top, and we're going to fill everything in. And we're going to figure out what everything means vocabulary-wise, because a lot of vocabulary here. So enthalpy of sublimation. What the heck does that mean? Sublimation is going from a solid to a gas. So Mg starts off as a solid, and I'm going to add it. Sorry, not going to add it. I'm going to turn it into Mg as a gas. So that is sublimation. You went from a solid to a gas, skip the liquid phase, and it has a cost. The delta H for that particular piece of the process is plus 146. Okay, ionization energy is when the Mg gets a charge. So Mg as a gas is going to turn into Mg plus 1 as a gas. So that's the first ionization energy. So remember, ionization energy, you're taking electrons away, they're getting charges. So that's going to be plus 738. The second ionization energy is plus 1451. So that's number 2. So Mg plus 1 as a gas turns into Mg plus 2 as a gas. So for the second ionization energy, it's going to be even more energy because it takes more to pull that second electron away. So that's plus 1451. So you see, I'm just kind of going down the list, and I'm kind of turning it into what I need. And so we need to create the Mg plus 2. How much energy did that take? And now the next line, kind of confusing on the next line, says the bond dissociation energy for fluorine is plus 159. What the heck does that mean? Okay, bond dissociation means you're breaking bonds. So we had F2, and that's a gas, And dissociation means that the F2 breaks apart into two individual Fs. And for that to happen, it was plus 159. Electron affinity is when the F as a gas becomes F minus 1. So it grabs an electron, but you have to write it just like they say there. So it says F. So F, going to erase that plus sign. I'll put that back in a minute. F as a gas turns into F minus 1 as a gas, and the delta H for that to happen was negative 328. And the last line says the enthalpy of formation is negative 1124. Enthalpy of formation is normal chemistry. So this is normal. So you might want to write that enthalpy of formation is normal. Regular old chemistry, whatever that looks like. So let's think about this. We know how to make MgF2. It's really easy. Mg as a solid plus diatomic fluorine as a gas is going to give me MgF2 as a solid. And I'm kind of running out of space here, so the delta H for this is negative 1124, negative 1124. All right, so make sure you get that negative in there. So now what we do is we, just like in Hess's law, we have a target equation. This is the target equation at the bottom, the normal chemistry. And so we're just going to add all of these up. And what we want them to do is we want everything to cancel out except for these items down here. So we want to keep this and this and this. Those are the three chemicals we want to keep. So we got to find them in here and keep them. Well, here you go. Here's one of them right away. That's a keeper. We're going to keep that. And so I like to circle the ones I keep. So I'm going to keep that. So I got this one. Check. Mg as a gas is on the right and it's on the left. So let's change pens so we can see that a little bit better. That cancels with this one. Mg plus 1 is on the right and the left, so they're going to cancel. Mg plus 2, it's on the right, and look, it's way down here. See, all of these that we're adding can cancel out. F2 is a gas. Okay, well, we need F2. We need to keep it because, look, it's right here. Boom, we're keeping that. And now we want to cancel. But wait a minute, I got 2 here and only 1 there. It doesn't work. I can only cancel 1. I need to cancel 2. So here's where you have to modify. I'm going to modify all of this by multiplying by 2. So multiply that by 2. Multiply this one by 2. Like that. And I'm going to multiply this by 2. So this whole line, that's what you got to watch out for, is you're going to have to make at least one change in each of these for them to work. So that's where you could get into trouble. So, but if I do that, I can cancel those with those. That's awesome. And then these, oh, look, we made a mistake. We forgot something. Why did we make a mistake? What the heck happened here? Made a mistake. We didn't balance that. That's my mistake. I just wrote that in. I needed to put a 2 right here when I initially wrote that down, because see, it's Mg and 2 F minuses will give you 1 Mg and 2 fluorine. So lattice energy, you always have to keep this value a 1. So you only can do the balancing on this side, because the definition for lattice energy is for creating 1 mole of your solid. So anyway, I forgot that too when I wrote that down, but I caught it when I got to this, because I'm like, okay, I got 2 here, but only 1 down there. So we still caught it. It's not going to change anything, but it wasn't canceling, which is a problem. It now does. Right side of the arrow, left side of the arrow. And then, of course, we need to keep this because of that right there. If you do everything like this and you get everything to cancel and the only thing that's left is the things you want, so you want this, I want this, I want this, and I want this. If everything else cancels, then you just simply add all these numbers up, okay? So we're going to add them up and we're going to see what we get. I don't have a ton of space here, but we'll carve out the answer. So let's get our calculator out. So we're solving for this down here, the question mark, right? So that is your x. So like if we think about in math, you really should just take mathematically to solve for x, you're going to take the negative 1, 1, 2, 4, and we're going to subtract everything else, and that will give us x. But you can do it however you want, but remember, it's just a big addition problem, and so all those are going to be added up. So let me go ahead and add in another slide here. And so when you're solving for the x, you just want to make sure you kind of understand how to do it in your calculator. So you would take the negative 1, 1, 2, 4, and then so that, because that's like the answer, right? And then to get this figured out, we're going to end up subtracting everything else. But so that's the answer. So it equals all of the other parts and the x, right? So got to make sure you have them down right. So it'd be 146 plus the so I'm just going down the list. 146 plus the 738 plus the 1,451, kind of run out of space here, plus the 159. So you're just going down the list, right? I did this one and this one and this one and this one. And now there's the negative 328 times 2. You can't forget the times 2. So plus, but this is negative 328 times 2. And then there we go. Now I'm going to put a bracket around this whole thing. Plus x. And you've got to solve for that x. Okay? So when you run this whole thing through your calculator, you should get the right answer. So I'm going to do it on my calculator. So I'm going to take negative 1124 minus 146, enter, minus 738, enter, minus 1451, enter, minus 159, enter, minus, in parentheses, negative 328 times 2, enter. If you do all of that, the delta heat lattice equals negative 2962, right? So hopefully you can get that mathematically, but I just did the algebra, right? All of these plus x equal that. So all right, I'm going to pause this one. Don't have enough time to do number 12 because you can see these take a ridiculous amount of time. But you're going to either solve for this piece or this piece.